The third and final biomechanics video looks at the centre of mass and stability. Again, both very important in terms of many of our sports skills and activities. So the specification needs you to be able to define centre of mass and look at the changes in centre of mass based on the position that you're holding and the area of support. Give some practical examples, obviously, in any exam question. So, mass. What is mass? It's defined as the amount of material of which an object is made of. So you can see from this picture here, these two athletes are of a large mass and a significantly smaller mass, and he looks quite traumatized by the idea of fighting him. It's not just the amount of mass that's important when we're looking at this, or the influence of the centre of mass. It's the distribution of mass, so where the mass is in an object or how it's spread. So let's look at centre of mass. For a typical male, this red spot should show you where the centre of mass is often located, around about belly button position. For females, however, it can often be a little bit different depending on their body shape. So you might find females tend to have greater mass around their bum and thighs, and guys might have a slightly larger or different distribution of mass. So the centre of mass might be a little bit lower for females. Now, distribution of mass also applies to any objects being held. So this athlete here, because there's a rather large mass being held above his body, the distribution will be slightly different, and you can see from the red centre of mass blob that it's a little bit higher to represent and to account for this mass being held above head height. So finally, this gymnast who is doing a pike jump, perhaps on a trampoline, you can observe here that the representation of the centre of mass red blob is actually not inside their body, but actually in the gap in between their body where the torso shape goes around it. So an important point there is centre of mass does not necessarily have to be within the object, it can be outside of the object, but it still represents the distribution of this object's mass as a whole. So, centre of mass, the point at which the body is balanced in all directions, and this point represents the distribution of that object's mass, or that body's mass. So here we have centre of mass again represented by the red dot, and we're introducing gravity to discussion now. Now, gravity acts through or down through the centre of mass, so this green line here is actually called the line of gravity, where gravity is acting through the centre of mass, and it's really important in terms of what discussions as we're going to go into now on stability. So again, the centre of mass has different positions depending on the body position of the athlete, and again remember it can be outside of the actual body, but the line of gravity will always act through the centre of mass. So here I've added the line of gravity. This example here shows the line of gravity being well between their feet, the feet being the base of support, which means this is quite a stable position. This line of gravity is getting near the outside of the base of support, so this might become more unstable, and actually this athlete might tilt forward. So that's just another factor. An important term then, line of gravity. So let's compare these two techniques of high jump in terms of centre of mass. This is called the Western roll, and it's a technique that was historically used as the norm for going over the high jump. And then came along Dick Fosbury, who invented the Fosbury flop, and you can see it's quite different in body position and technique. So centre of mass for this athlete here doing the Western roll is quite clearly above the bar. So this athlete would have to generate a large amount of force to get the, not just the body, but the centre of mass well above the height of the bar to get him over clearly. So centre of mass for the Fosbury flop, based on this new technique and this different body position, is below the bar. And the implications for that is that because the centre of mass passes under the bar, it actually demands less energy and less effort for the athlete. So the technique makes it easier for the athlete to clear the bar and actually uses less effort and energy to do it. So just a little bit of information. We know doing a jump, or in this case it looks like a layup example, the athlete applies a force to the ground, and the reactive force in this case is going straight through the centre of mass and will make that athlete jump upwards in that direction. However, so when a force is applied through the centre of mass, we get a linear movement, a linear jump. However, if the reactive force actually is applied outside of the centre of mass, so this is an athlete just going into a high jump to go over a bar that would be up here, you can see that what we start to create is angular motion. So the force is applied on the ground, the reactive force is opposed in the opposite direction, which in this case is outside of or away from the centre of mass, and this athlete as a result will generate angular motion. So that's the direction that they'll go off in, and they'll go hopefully up and over the bar. So where the force is applied in terms of the centre of mass does contribute to the outcome. So stability. In sport, you sometimes want to create stability, and sometimes you want to reduce stability or create instability. So looking at these two athletes here, there are some important factors. So centre of mass for this athlete would probably be around about here. The line of gravity would go down through her foot, and her foot in this case is called the base of support, which actually a foot is probably quite a small base of support. If she were to change position and her centre of mass moved here, that line of gravity then goes outside the base of support, and what this will do is mean that she will want to topple forward. Or if the centre of mass moved backwards, again the line of gravity brings it down outside the base of support, she'll want to topple backwards. So she is only balanced because her centre of mass is directly above her base of support, but it's a relatively unstable position. It's got a very small leeway in terms of being balanced. This guy, centre of mass is probably around about here. Directly the line of gravity takes you down, and he's got a relatively wider base of support. So the line of gravity being within the base of support means that he is fairly stable. If he gave himself a much wider stance, he would again be considered even more stable because there's a greater leeway to remain balanced. So stability relates to how difficult it is to disturb a body from a balanced position. So this girl, it would be quite easy to disturb her in terms of making her unstable, making her unbalanced. This guy, a bit more stable, you'd have to do a lot more to make him unbalanced. So just to sort of sum up the key terms here: centre of mass representing the distribution of mass of a body. The line of gravity, so the gravity line comes down through the centre of mass, and the base of support, the contact points with the ground that are so important in terms of balance and stability. And where the line of gravity is within the base of support, there is stability. However, things that can challenge stability are the height of the centre of mass. So this chappie, who's about 2 foot taller than this original young man, you can see the height of the centre of mass is higher, and the base of support is narrower. Now both of those factors will make him less stable than him. If he wanted to become more stable, the first thing he should do is widen his stance, maybe put this foot over here so he has a larger base of support, and if he bent his knees also, he would lower his centre of mass. And again, the widening the base of support and lowering the centre of mass both increase stability. So have a look at these two gymnastics positions. We've got a headstand and a handstand. Just have a quick think about which you think is slightly more stable and why that might be. Well, hopefully you decided that the headstand here is a little bit more stable, and let's look at why. So the head and the two hands basically create a triangular base of support. The centre of mass of this athlete is probably about here and would be very much within that triangular base of support. So she's in effect made a tripod, like a camera tripod, which you should know is fairly stable. This handstand athlete, however, just has a line, 2 points of contact as a base of support. So they're sort of vulnerable to wobbling in this direction. They don't have that triangular base. The centre of gravity would ideally be along or between that base of support, those two hand positions, but is very vulnerable to a minor change in that direction or a minor change in that direction before they become very unstable. So headstand much more stable because of this tripod triangular base of support. It has a lot of leeway in each direction, and this handstand position is much less stable. And again, sometimes in our sport we intend to create instability, often to change position or go into another skill. So the girl here who's going into a cartwheel actually purposely moves her body position, lifts a leg, shifts by her arm position her centre of mass outside of this now singular base of support, and she will create rotation ready to go into, or where she puts her hands down on the ground to go into her cartwheel. So weight causes her to topple to the side, and she'll then rotate on the ground going into the cartwheel. Another example might be a dive on a diving platform or on a diving board, or even the side of the pool. You stand upright, you tilt forward so that your centre of mass moves forward outside of your base of support where your feet are in contact, and then you eventually push forward with or push up with your feet, causing you to dive. But you've created instability by leaning forward and moving your centre of mass outside of the base of support. So the gymnast needs to create stability to initiate the cartwheel in the same way a diver would, and the centre of mass moves outside the base of support. So we've looked at centre of mass, and we've looked at the line of gravity and the base of support, and how they are critical in terms of either creating stability or creating instability. But you need to know what factors will change stability. So definitely the height of the centre of mass and the base of support.